Is it recording, Matt?
Yeah.
Okay. All right, about a week ago, I know it's been a while, I started off, I drew a triangle in quadrant 1, and we called this point X and Y, and we named that side X, that side Y, and that's R. So we started off with the Pythagorean theorem that these two legs squared added together is equal to the hypotenuse squared, right? Then we said, let's divide everything by R squared. If you divide everything by R squared, you have X squared over R squared, which is cosine squared. X over, don't we all agree that cosine is X over R? So then if X squared over R squared is cosine squared, and Y squared over R squared is sine squared, and R squared over R squared is 1, we have this identity. Okay, this is where it came from. Everyone with me? So does everybody have this one embedded in their mind? Cosine squared plus sine squared equals 1. So where did it come from, Trevor?
It came from the X.
It came from squaring each of these using the Pythagorean theorem. Okay, now,
She's pointing at the X.
we can take this identity and we can transform it into a couple more. What could we do with this?
Subtract steps.
We could subtract and make 1 minus sine squared. And we can also write this as sine squared. And all I did was move either this over or that over. Is that okay with everybody?
Yep.
Now, another thing you can do is you can take this identity, let's go back to the basic. Where did it come from? We squared each side and then divided by R squared. So we can take this one and let's just divide everything by cosine squared. We're just pulling this out. We're going to divide everything by cosine squared. Now let's talk about a new identity that's going to come out of this. What is anything over itself? What does this equal? 1. Do you remember what this equals? What's sine over cosine? Tangent. And 1 over cosine is secant. So now we have another identity that came from dividing everything by cosine squared x. Now what can you do with this one? You can subtract tangent squared x. Okay, so you can get that one from this. And you can also subtract 1. You can say tangent squared x is equal to secant squared x minus 1. What else can you do with this formula? Cosine squared x plus sine squared x. You can divide everything by sine. What do you get now? What's this? This is cotangent. This is 1, and this is cosecant. So now we have 2 more that we can transform from this. We have 1 equals cosecant squared x minus cotangent, and you have cotangent is equal to cosecant squared minus 1. Now, why do you need these? Why do you need to know all these?
Why?
Because you are going to be asked to prove many more identities. We're just going to practice these 3 because these are very similar to what is on your test tomorrow. If you take it tomorrow. If you don't take it tomorrow, you take it Monday. If you don't take it Monday, take it Tuesday. Okay, so we did this one. See if you can tell me. You're going to use factoring. You're going to use adding, subtracting, and rewriting things in terms of sine and cosine in order to prove one side equals the other. So we want to prove that secant fourth x minus tangent fourth x equals 2 tangent squared x plus 1. So does anyone see something that you can do? This is called the difference of 2 perfect squares. How would you, let's start off by factoring this. How would you factor this? factoring. The difference of two perfect squares. Now, let's look at our identities. Do you see something that you can substitute? We just did this. So the first thing I do when I do my identities is I write sine squared plus cosine squared equals 1, and then I write all the other ones. Why? Because this helps me. We just wrote this all out. This will help me now look at, does anybody see something that we can substitute? You have secant squared x minus tangent squared, and then secant squared plus tangent squared. So which set of identities are you going to look at? Are you going to look at the ones with cosecant?
We can set the
No.
first one equal to 1.
Say, yeah, what is it, John?
We can set the first one equal to 1.
Yes, secant squared x minus tan, this is equal to 1. So this is what we have now. So this binomial equals 1. What's 1 times anything?
Itself.
Itself. So what you have now, you have secant squared x plus tangent squared x. What are you trying to get this side equal to? We need 2 of the tangent x's. So we want to leave this one alone. We just want another tangent squared x. So let's look again at our identities. What could I rewrite secant squared? So let's look at it. What can I rewrite secant squared? What is it?
1 over cosine. Am I right?
Look at these identities right here. What is secant squared x equal to?
1 plus tangent.
Mm-hmm. So now secant squared is 1 plus tangent.
That's your answer.
And what's a tangent squared x plus it? These are like terms. What do you get here? Say it. 2 tangent squared x plus 1. So we just proved that this side equals that side.
Okay.
So,
The problem's gonna be memorizing all those values.
All you have to do, you guys, is just memorize this one. And know that also you do have to know cosine over sine is cotangent. And sine, you have to know sine over cos, you have to know these two. You have to know those. Yes.
How'd you manage to get the 2 tan?
Wait, which one?
you're combining like.
Put that back. And these are all in your notes. I gave these all ready to you guys in your notes in section 9.1. Okay, Nick, what was your question? I'm sorry.
It's fine, Troy got it.
Are you sure?
Mm-hmm.
You asked me, how do you know that these are like terms. You have a coefficient of 1. 1 plus 1 is 2. Okay, this next one. When you see the word cosecant or secant or cotangent, you can rewrite them as in what? What's another name for cosecant?
1 over sine.
Mhm. What's another name for cosecant? And what's another name for cotangent? Everybody see, I'm working on this side right here. Now the reason why I chose not to work on this side, because I really don't know what to do here. I know that I can replace cosecant for something in cotangent. Does everybody see what I did? I just rewrote these. Now, what is this asking you to do?
I'll have to strip.
Multiply. What do you think 1 sine times 1 sine is? What do you think this product is? What's this times this?
Over 2 sine.
Not 2. What's sine times sine?
X squared.
Sine squared x. Good. Now, what do you think 1 over sine times cosine x over sine x is?
Cosine over sine squared.
Mm-hmm.
Sine squared x.
Very good. Now, what are they asking you to do with these two fractions? Add them. What do we know about fractions? They have to have the same denominator. Do these have the same denominator?
Yeah.
Yes.
So what do you add together? Do you add the bottoms?
No, the top.
No, you just, you
bottom.
leave the bottom the same, and you just add the top. Is everybody with me?
Yep.
Okay, now I'm stuck. Now I have to replace something. What am I gonna replace sine squared with? That's the only thing I can replace. Now go to your identities. What is sine squared x equal to? 1 minus cosine, so let's replace it. Okay, now, isn't this factorable? Isn't this the difference of two perfect squares? How does that factor that bottom? How does the bottom factor?
One plus one minus.
Mm-hmm. Whoops, one's a minus, sorry. That's this is a minus. I'm using pen. What cancels?
The 1 plus
What's left on top of 0?
1.
No, 1. Someone asked me, isn't 0 left? No, 1's a plus. Guess what we have?
Answer.
The answer, 1 over 1 minus cosine x.
That's
Okay, number 3. Look for something that you can rename. Now, would you want to work on the right side? No, because you're going to write that as 1 over cosine and then you're stuck. So there's more stuff to do on the left side. Like, I know I can rename this. I know I can rename this. And I can write that as something. What's cotangent? What's another name for cotangent? Cosine over sine. And I'm not putting the x's. You can put that in after. What's another name for cosecant?
1 over sine.
Mm-hmm. And then this is 1 over sine. Now, how do I get these two together? These two right here. I can't, right now they're separate. I have to get a what? Okay, so watch, I'm doing it right now. I'm gonna multiply this by sine x and this by sine x. So what you have here, on top, you still have cosine of x over sine of x. And on the bottom, you have 1 minus, what's this? Sine squared x over sine x, right? Now, you know the flippy part, flip and multiply? What cancels here? If we were to flip this and multiply, what's gonna cancel?
Sine.
These two would cancel, right? So what you have here is cosine over 1 minus sine. What's another name for 1 minus sine squared x?
Cosine.
Uh-huh. And guess what you have here? You have 1 cosine, and you have 2 cosines. I want to write cos. What cancels? What do you have? 1 over cosine. What's another name for 1 over cosine?
Secant x.
Done. If you can follow those major things to do, rewriting, combining, fact distributing, rewriting, if you know those identities, you shouldn't have a hard time.
This is on the test, right?
Yes.
Wonderful.
Mhm. Now, over the last couple days, we've been working on these identities. Do you remember if it's a sine, I'm gonna put my finger over that. Do you know how to break this up? You're gonna know these. It's the sine, it's a subtraction one. It's the sine of the first angle, cosine of the second angle, same sign, minus the product of those two. So, how do you break this up? This is gonna be the sine of the first angle times the cosine of the second. Same sign, you use the same sign. So minus the sine of the second angle times the cosine of the first. Everybody with me on that? That's this. I just wrote those two. Now plus. That's this plus sign right here. Now we want to break this one up. This one's going to be sine of the first angle times the cosine of the second angle. Same sign, sine of the second angle, cosine of the first. Now look at this for a second. It's asking you to simplify. I'll bet you something can be simplified. What simplifies? Think of canceling and combining like terms. What cancels? What looks the same?
Thus,
This is really algebra. This is an algebra problem.
There's 3 that are the same.
yeah,
There's 3 that are the same?
yeah,
No, there's only 3.
there's 3.
No, there's 3.
The
What
first
did I write wrong? Sine of the
Yeah, you
first,
wrote the second
You
one
wrote
wrong.
cosine second, sine
Sine
of,
of
this should have been y,
Yeah,
and cosine of x. Sorry, guys.
you can cross out the sine of y, cosine of x. Cross both of those out.
These two get crossed out,
So then you get
and then what do you have?
2 sine of x.
2 sine x cosine y. That's that answer. Next one. Do you remember this identity? It's a plus, it's a tangent with a plus. It looks like this. The tangent of the first angle, same sign, tangent of x, over 1, then this is going to be an opposite. Now, if this is a minus here, that'll be a minus, but that'll be a plus. And then you do the product of these two. Now, I bet you tangent of pi, where's pi at, everybody? Right here. This ordered pair is 0, -1, 0. What's the definition of tangent? Y over x. What is 0 over anything?
0.
So what does this equal?
0.
This is 0, and this is 0. What's 0 times anything? What's 1 minus 0? 1. What's left here?
2.
That's simplified. That's it. Okay, this identity. It's a cosine with a subtraction. It looks like this. Cosine of the first angle times the cosine of the second angle. Opposite sign for cosine, so now I'm going to put a plus sign. And then it's the sine of the first angle times the sine of the second angle. Well, where the heck is pi over 2? Right here, 0, 1. And what's the definition of cosine? It's x over r. What is this equal to right here?
0.
This is 0. What's this equal to right here? 1. What's 0 times anything?
0.
This is nothing. They all goes to 0. And what's 1 times sine of x?
Sine of
That's it. Backside. Now this one, look at this right here. Cosine, cosine, sine, sine. These two are the same, and these two are the same. Again, cosine, cosine, sine, 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 the first angle and the second angle. Which identity? You're not doing any distributing here. I want you to focus on, is this a cosine identity or a sine identity? Which identity does the cosine, cosine, sine, sine? Cosine. And you're going to take, this is going to be your first angle, so we'll call this A. This is the A one, and this is the B one. So it's the cosine of A, and then you're going to change opposite sign, so this is going to be a plus B. Well, what is A? This is A. So it's the cosine of x minus y plus y. This is b. These are gonna cancel, and your answer is cosine x. So look at this problem as the cosine of the first angle times the cosine of the second angle. Opposite sign, so that's why I'm adding. Now, what do you think this one is? Sine, cosine? And now, you know what? You can write this. I like to write the sine one this way, and it's the same thing. You can switch these two around. But which identity? Is it sine or cosine that switches them? Sine, cosine, sine, cosine. It's a sine. And sine is same sign. So I have to figure out what angle A is and angle B. It's 7 and 3. We're going to do what to 7 and 3? Add them. What's 7 and 3? 10. Okay, the next one. Cosine of 5 pi over 12. What we did was we took our identities, our angles, pi over 6, pi over 4, and we converted them into 12s so that we can add these two up. 2 pi over 12 plus 3 pi over 12 is 5 pi over 12, right? Is it? 3 pi over 12 plus 2 pi over 12, isn't that 5 pi over 12? Yes or no?
Yes.
Well, what is another name for 3 pi over 12? You know what, can you come back? I'm videotaping right now and
Oh,
I'll be done in like,
well, I'm
15 minutes.
leaving now, so,
if you can come back in 10 minutes, I can get it for you. I can't get it for you now.
okay, I'll try, but,
Okay. So pi over 4 is 3 pi over 12, and 2 pi over 12 is pi over 6. Is everybody okay with that?
Yeah.
So now, what do you do with this identity? It's the cosine of the first angle times the cosine of the second angle. Opposite sign, subtract, because this is a plus, you're going to subtract. And then it's the sine of the first angle, and then sine of the second angle. When I say first angle, second angle, I'm talking about these two. Well, where is pi over 4? Pi over 4 is a 45. This is root 2 over 2, and so is this, root 2 over 2. This is a 30-degree angle, and a 30, these are the ratios. So cosine of 30 is root 3 over 2, and sine of 30 is 1/2. You gotta know how to multiply these radicals. This is gonna be root 6 over 4 minus root 2 over 4. And so your exact answer would be root 6 minus root 2 over 4. Okay? Next one. What 2 degrees will add up to be 105?
Pi over 4, pi over 3.
Don't convert it into, think of the circle, you don't have to, you're doing too much work.
65 and 60.
45 and 60. 45 plus 60, doesn't that add to be 105? So you're gonna do the same identity, it's the sine of the first angle times the cosine of the second. Same sign. So sine of the second, cosine of the first. Well, sine and cosine of 45 is root 2 over 2. And this is a 60-degree angle. So here's our 60. Cosine of 60 would be 1/2. And this is root 3 over 2. So what's this answer? Root 2 plus root 6 over 4. Root 2 plus root 6 over 4. Root 2 plus root 6 over 4. Next one. How do you get 75 degrees with the angles that we know?
45.
Okay, how'd you do it? 30 plus 45 gives us 75, right?
Yeah.
So what does the tangent identity look like? It looks like the tangent of the first angle plus the tangent of the second angle over 1 minus the product of these. Well, tangent of 45 is 1. This is equal to 1, and this is equal to 1. This is a 45-degree angle, 1, 1. What about a 30 degree? Here's 30. This is 1, and this is root 3. So you could write it as 1 over root 3, or you could rationalize it. This is going to be root 3 over 3 plus 1 over 1 minus root 3 over 3 times 1. Now, we'll call that that's not simplified yet. So I need a separate sheet of paper for me. I'm going to have to give you more room. So this is what you have. Now, how do you do this problem? This is an algebra problem, believe it or not. How do you add the numerator up? How do I add these two up? What do I have to turn 1 into?
133.
Huh? What do I turn it into?
3 over 3.
What? 3 over 3. Did everybody catch that before I write this? This is root 3 over 3 plus 3 over 3 over 3 over 3 minus root 3 over 3. On top you have root 3 plus 3 over 3. On the bottom you have 3 minus root 3 over 3. Does anyone know what happens to these two 3's?
Cancel.
They cancel out. This,
Negative.
nope.
Just kidding.
This is called the unrationalized answer. And since this is a pre-calc class, we expect you to take this answer. And if you want to write it as 3 plus root 3, it's the same thing. How do you rationalize this denominator? What do you multiply by?
3 plus 3, yeah.
Okay? Now let's simplify, or let's FOIL. 3 times 3 is 9. Then we have 3 root 3 plus 3 root 3 is, everybody?
6 root
6 root 3. What's root 3 times root 3?
3.
3. And then the bottom, you have 3 times 3 is 9. The next two cancel out, and then you have minus 3. Well, let's simplify this. What's 9 and 3?
12. 5, 6.
Now, what cancels? 6 goes into 12 how many times?
Excuse me, plus root
And don't forget, you're canceling this. You have to do it twice, so that is your final simplified answer. This is an exact answer. Okay, almost done. Almost done. So let me write these answers for those that need it. Okay, this last two. This one says, sorry I wrote on here, cosine of x is negative 4/5. Where is x at? Look at this little stipulation here. Where does x lie? Is it in quadrant 1? Where is less than pi but greater than pi over 2? Where am I at? That's important to understand where you are, because that's going to tell you what side, what x, the legs are going to be positive or negative. That's important. You will get this problem wrong if you don't understand what this means. This is telling you that x, it's less than pi, but bigger than, so it's in quadrant 2. Now go back to this problem. It's telling you that you have cosine of x is negative 4/5. So what is the definition of cosine? Adjacent over hypotenuse. What am I going to name this side as? Why? Pythagorean theorem. Is it a positive 3 or a negative 3?
Positive.
Now, if I would have told you you were in quadrant 3, I would have drawn a triangle in quadrant 3 and I would have named this leg negative 3, right?
Yes.
All right, now, this is what they want you to do. So can you tell me how to expand this identity? It's the cosine of the first angle times the cosine of the second angle, opposite sign. Sine of the first angle, sine of the second angle. Well, when I say cosine of pi over 4 and sine of pi over 4, what am I referring to?
Root 2
A
over 2.
45-degree triangle. When I say what's the cosine of x, I'm talking about this, which is negative 4/5. And this is gonna be 3/5. Are you with me? So this is negative 4 root 2 over 10 minus 3 root 2 over 10. And what's this answer?
-7.
This is make sure you have the opposite sign. So this is a plus sign, you should have a minus here. What's this final answer? -7 root 2 over 10. So that's your final answer, -7 root 2 over 10. Last one. We have two letters, sine and we have cosine. X is located where? Where's X located?
First quadrant.
Mm-hmm.
Please excuse this interruption. If we could have the varsity baseball players, please be excused from their class at this time. Thank you.
Y is in quadrant 2 because this tells you you're less than pi but greater than pi over 2. Now how are we going to name, what's the definition of cosecant? Hypotenuse over, what's this side going to be? Negative what?
12.
-12. Why did I write negative?
Yeah, it's-
Because it's in quadrant 2 and x is negative in quadrant 2. So we want to simplify that. We want to know what sine of x plus y is. So let's write the identity out. It's the sine of the first angle times the cosine of the second. Same sign. Sine of the second, cosine of the first. Well, when I say sine of x, I'm talking about this triangle, x, 4/5. When I say cosine of y, -12/13. When I say sine of y, I'm talking about 5/13. And when I'm talking about cosine of x, 3/5. What do you get here? What's 4 times -4 times -12? -48 over 65 plus 15 over 65. What's my answer?
-33.
Mm-hmm. You got it. And that's it. You need to know those identities.